You think you see the world as it is. Light hits your eyes, sound enters your ears, and your brain passively records reality like a camera. But that's not what's happening. Your brain is not a passive receiver. It's a prediction machine. Right now, it's generating a simulation of the world based on past experience, and then checking that simulation against incoming sensory data. What you see, hear, and feel is not reality itself. It's your brain's best guess. And most of the time, you're hallucinating. Controlled hallucinations, yes, but hallucinations nonetheless. Welcome to predictive processing, where perception is an inside-out process and reality is whatever your brain decides it is. For most of history, we thought perception worked like this. Sensory data comes in through your eyes, ears, and skin, travels up to the brain, and gets processed into a coherent picture of the world. Bottom up. Data in, perception out. Simple. But neuroscience has revealed something far stranger. Your brain doesn't wait for data to arrive before forming a picture. It constantly generates predictions about what it expects to experience and then compares those predictions to the actual incoming signals. When predictions match the data, you perceive smoothly. When they don't, your brain updates its model. Perception is not a recording. It's a real-time simulation being corrected on the fly. This framework is called predictive processing, or predictive coding, and it's revolutionizing how we understand the brain. The theory says that your brain is fundamentally a prediction engine. Its job is not to represent reality accurately, but to minimize prediction error, the difference between what it expects and what actually happens. Every layer of your brain, from low-level sensory areas to high-level conceptual regions, is engaged in a constant cycle. Predict, compare, update. Your conscious experience is the brain's best current hypothesis about the causes of its sensory inputs. Think about vision. You assume you see the world in full, vivid detail everywhere in your visual field. But you don't. Your eyes only have high-resolution sensors in the tiny central region called the fovea. The rest of your visual field is blurry and low resolution. Yet you don't notice this. Why? Because your brain fills in the gaps. It predicts what's in the periphery based on context and past experience. You think you're seeing the whole room clearly, but you're actually seeing a detailed model of the room that your brain has constructed. When you move your eyes, the model updates. Most of the time, the model is accurate, but sometimes it's not. And when it's not, you experience illusions. Consider the famous checker shadow illusion. A checkerboard with a shadow cast over it. Two squares, one in shadow, one in light, appear to be different shades. But they're the same color. Your brain knows that surfaces in shadow should look darker, so it adjusts your perception to compensate. It corrects the image so you perceive the squares as different, even though the light hitting your retina is identical. Your brain is not showing you the raw data. It's showing you its interpretation. This isn't a bug, it's a feature. Your brain's job is to infer the true state of the world, not to passively mirror sensory input. Most of the time, this works brilliantly, but it also means you can be fooled. Predictive processing explains a wide range of perceptual phenomena. Why do you stop noticing the feeling of your clothes after a few minutes? Because your brain predicted that sensation, matched it, and then suppressed it as unimportant. Why is the McGurk effect so powerful? Where seeing lips say one syllable while hearing another sound creates a third, phantom syllable. Because your brain integrates predictions from vision and hearing, and the final perception is a compromise between the two. Why do placebos work even when patients know they're taking a placebo? Because expectation shapes perception. If you expect pain relief, your brain predicts reduced pain signals and adjusts accordingly. The theory also has profound implications for mental health. Many psychiatric and neurological conditions can be understood as disorders of prediction. In schizophrenia, patients may have difficulty distinguishing between internally generated predictions and external sensory input. The brain generates predictions, thoughts, images, voices, but fails to tag them as internal. The result: hallucinations that feel externally real. In autism, some researchers propose that prediction mechanisms are altered, leading to hypersensitivity to sensory details and difficulty with generalization. In anxiety and depression, the brain may overpredict threat or underpredict reward, creating persistent feelings of danger or hopelessness, even when reality doesn't justify them. Chronic pain is another striking example. Pain is not just a signal from damaged tissue. It's an inference. Your brain predicts danger to the body and generates pain as a protective response. Sometimes, after an injury heals, the brain continues to predict pain in that area. The tissue is fine, but the prediction persists. This is why phantom limb pain occurs. Amputees feel pain in limbs that no longer exist because the brain's model of the body still includes that limb and predicts pain signals from it. Some treatments for chronic pain involve retraining the brain's predictions using techniques like mirror therapy or virtual reality to update the model. This brings us to a deeper question. What is you in this framework? If perception is your brain's guess, and that guess is constantly being updated, where does the real world end and your construction of it begin? The answer is unsettling. There may not be a clean line. Your experience of reality is always mediated by your brain's predictions. You never have direct access to the external world. You only have access to your brain's model of it. Philosopher Anil Seth calls this a controlled hallucination. You're hallucinating all the time. The control comes from sensory data, constraining and correcting those hallucinations. But the hallucination is still yours, not reality's. Some predictive processing theorists go even further. They argue that not just perception, but selfhood is a construction. Your sense of being a unified I is a model your brain generates. It predicts your own internal states, emotions, thoughts, bodily sensations, and integrates them into a coherent narrative. When those predictions are accurate, you feel present and embodied. When they go wrong, you might experience depersonalization or derealization, the eerie sense that you or the world aren't real. These are prediction errors about the self. If the self is a prediction, then consciousness itself might emerge from the process of prediction and error correction. This is speculative, but some theorists propose that conscious experience is what it feels like to resolve prediction errors at high levels of the brain's hierarchy. When predictions match the world smoothly, you process on autopilot, unconsciously. When mismatches arise, attention is recruited, and you become consciously aware. Consciousness, in this view, is the brain's way of flagging surprises and updating its model. You become conscious of what you can't yet predict. This also connects to learning and memory. When you encounter something novel, an unexpected sound, a new concept, your brain's predictions fail. That generates a prediction error signal. The brain then updates its internal model so that next time the prediction is better. This is learning. Memory is not a storehouse of facts. It's a set of updated predictions. When you remember an event, you're not retrieving a recording. You're reconstructing a prediction of what happened based on fragments and context. This is why memory is so malleable. Every time you recall a memory, you're repredicting it, and the prediction can change based on your current state. False memories fit naturally into this framework. If your brain's prediction machinery is fed misleading information, a suggestive question, a doctored photo, it integrates that into the model. The next time you remember, you predict based on the updated model, which now includes the false information. The memory feels real because the prediction is confident. But confidence is not accuracy. Your brain doesn't know the difference between a prediction based on real experience and one based on suggestion. Both feel like memories. Now, let's talk about action. Predictive processing doesn't just explain perception, it also explains movement. When you decide to lift your arm, your brain doesn't send a command to muscles and wait. Instead, it predicts the sensory consequences of lifting your arm, the feeling of the arm moving, the visual feedback of it rising. It then minimizes prediction error by making those predictions come true. Your motor system adjusts signals until the predicted sensations match reality. In this sense, action is perception in reverse. You perceive by predicting what the world will cause in your senses. You act by predicting what your body will cause in the world and then making that prediction accurate. This has strange implications. Your brain can sometimes mistake imagined actions for real ones. When you vividly imagine moving, similar neural areas activate as when you actually move. In some cases, like certain delusions of control, patients feel that their actions are caused by external forces. Their brain's prediction of, "I am moving," is disrupted, so the movement feels alien. The boundary between thought and action, between prediction and reality, is thinner than it appears. Predictive processing also sheds light on meditation and altered states. When you meditate, you often focus on a single object: breath, a mantra, a sensation. This stabilizes your brain's predictions. There are fewer surprises, fewer errors to correct. The constant churn of prediction and updating quiets down. Many meditators report a sense of spaciousness, presence, or even ego dissolution. In predictive terms, the brain's model of self, which normally updates constantly in response to internal and external surprises, becomes less active. The I is a prediction that, when not reinforced, fades. What remains is raw awareness, less filtered by expectation. Psychedelics may work in the opposite way. Compounds like psilocybin and LSD disrupt the brain's normal prediction hierarchies. High-level predictions like "I am a separate self" or "walls don't breathe" are weakened. Lower-level sensory data, normally suppressed, floods awareness. The result? The world looks strange, new, unpredictable. Boundaries dissolve. Colors intensify. The ordinary becomes extraordinary. Users report that the experience feels more real than normal perception, even though it's pharmacologically induced. In predictive processing terms, normal perception is heavily predicted and filtered. Psychedelics reduce the filtering. You see more of the raw prediction errors your brain usually resolves unconsciously. This raises a philosophical question. Which perception is more real? The stable, predictable world of sober waking life, or the chaotic, unfiltered vividness of a psychedelic state? The answer depends on what you mean by real. If real means matching the external world, then sober perception is more accurate. It's been tuned by evolution to track survival-relevant features. If real means less filtered by prior beliefs, then psychedelics might reveal aspects of sensory input normally hidden. But neither is direct access to reality. Both are models. One is just more tightly constrained by prediction. Predictive processing also has implications for artificial intelligence. Modern AI systems, especially deep learning networks, can be understood as prediction machines. They learn statistical patterns in data and generate predictions. When predictions fail, they update. This is similar to how the brain works, though the architectures differ. Some researchers are building AI explicitly inspired by predictive coding principles. These systems learn by predicting sensory input, not just by being told the right answer. They develop internal models of the world, and in some cases, they show emergent behaviors, like attention, curiosity, and generalization, that mirror biological cognition. If predictive processing is correct, then the brain is not fundamentally different from these AI systems. Both are pattern-matching prediction engines, minimizing error over time. The main differences are scale, substrate, and evolutionary tuning. Human brains have been optimized by natural selection to predict survival-relevant features of the ancestral environment. AI systems are optimized by engineers to predict features of datasets. But the core mechanism, predict, compare, update, is the same. This suggests that as AI systems grow more sophisticated, they may develop something like perception, attention, and even subjective experience if those phenomena emerge from predictive processing. But here's the catch. If your perception is a controlled hallucination, how do you ever know if your predictions are accurate? You compare them to sensory data. But sensory data itself is interpreted through predictions. It's predictions all the way down. There is no raw sensory input that your brain accesses directly. Everything is filtered, interpreted, predicted. So how do you escape the loop? The answer is, you don't. You live inside the loop. The best you can do is iteratively refine your predictions through interaction with the world. Science is an extension of this process, testing predictions, updating models, seeking coherence. But ultimate certainty is impossible. You are forever inside your brain's simulation of reality. This is not solipsism. The external world exists and constrains your predictions. If you predict that gravity doesn't apply and step off a cliff, reality corrects you, painfully. The world pushes back. But your experience of that world is always mediated. You see the cliff, feel the fall, but the seeing and feeling are your brain's renderings, not direct contact. You are a mind in a vat. The vat is your skull, and the simulation is generated by your brain based on sensory input from a real world you can never fully touch. So, what does this mean for how you live? If reality is what your brain decides, does that mean you can decide it differently? To some extent, yes. You can train your brain's predictions. If you practice gratitude, you start predicting positive experiences, and your perception shifts. If you catastrophize, you predict threats, and anxiety follows. Cognitive behavioral therapy works by challenging and updating dysfunctional predictions. Mindfulness teaches you to notice when your brain's model diverges from present moment reality. But you can't simply choose your predictions at will. They're shaped by genetics, development, and accumulated experience. Change is possible, but not effortless. In the end, predictive processing teaches humility. You don't perceive reality as it is. You perceive your brain's best guess, constrained by sensory input and shaped by expectation. Your world is a story your brain tells itself, updated every moment by surprise and correction. And everyone else is living in their own story. When two people disagree about what happened, it's not always that one is lying. They might genuinely have different predictions, and thus different perceptions, of the same event. Empathy becomes recognizing that others' realities, while constrained by the same external world, are constructed through different lenses. Your reality is yours, not in a mystical sense, but in a deeply physical one. Your brain made it, and every day, with every experience, you're remaking it, one prediction at a time.